Hey guys, it's Shisha here from How Git Works video series, session 2. Yeah, session 2. So agenda. So this video I'm going to talk about what is a Git commit branch header. These things are actually the most fundamental things I've learned about Git. I've spent some time to dig into the rabbit hole, and then it really helped me to gain the confidence. So hopefully you can follow me along with this video, and even if you don't follow the following videos, which are more higher level, I think you definitely would have gained more confidence of using the Git. Okay, so this is most important video in this whole series. So where we start? In that session we have dropped off from so we have this how Git works, and we have already enabled the Git, and even we have made one Git commit f145. That's the hash code of the Git commit, and now we're gonna check what that commit really contains. How does Git really track the changes and the file content in your working directory? So one Git command I'm going to introduce is called the git cat file. What it does is it read the hash code and then extract the content inside. For example, if I say git file -p, which means prettify the output format, f145. I don't need to type everything. 4 character is good enough. You can see it tells me this is actually the content of a file, the commit, and then it tells me the first line is like it says like it's the tree. There's another hash code, and then who is the author of this commit, who is the committer of the commit, and then what's the attached message to this commit. If we go back to this window with the git log, you see the attached message is here already. So now let me jump back, and I'm gonna introduce another thing. It's called tree-a. It prints out the current working directory as a tree kind of structure, and in this .git folder, it contains multiple folders and multiple files. As you can see, this objects subfolder, and it contains this fi45 something something. Actually, that is the commit Git saved in the .git folder. So it always go down to the objects folder, and then according to the hash ID or the hash code to locate a file under this object folder. So it means what we just run with the git cat file -p, it prints out the file. However, if we just use cat if one something and for something, it prints out like an encrypted message. So Git actually encrypt the data, and I think it also compress the data somehow. And then we need to use this git cat file to extract the data from the commits. Okay, now we try to speed things up. We already located the hash code of the commit, and we located the file of that commit in .git repository. And then let's see the hash code inside. It tells me there's a tree and there's a hash code. Then let's use this same cat file and use the hash code to see what it contains. Ooh, a new line. It says, okay, let me write it down now. So we have a commit, and then it points to a tree, and which also has a hash code, and then it points to a blob, which also has a hash code. And in addition to the hash code, we're gonna also copy it out and then check what's the content inside. It also it tells me the blob, and then is this 10 or something. This is like the user permission to this file. Is it like a read permission, write permission, or execute permission on top of this file? And then this is the readme.md. That's the file name. Okay, so now we're gonna check the blob git cat file. Yeah, I don't need all this. Sorry, I need to copy the blob ID and paste it here. This is the demo repo. What does it mean? It means the readme.md file contains the content of this is the demo repo. If we cat readme, exactly, this is the demo repo. So now what has actually happened is the commit is a unique hash ID, and inside that commit it points to a tree, and the tree has the author committer information, and then it points to another blob, which is also another file saved in the objects. Actually, as you can see, all these hash code files are saved here. And then the blob contains the real content. Basically, that's how it works. Pretty simple, right? It's like a tree from the commit file, then it links to all the whatever tree or blob or something else, right? So let's make the demo a bit interesting. Let's try to make another commit. So this time what I'm gonna do is I'm gonna create a file called cd, yeah, and then I'm gonna create another file called the cd.md. This is a cd file. Okay, so come on. Yeah, what I just did is I create the folder, create the file, and then the git status. I see, okay, cd is here, git add cd, git status. Yeah, you see, I now already pushed, let's say, I added this file, which means I pushed the change into the staging area. If you don't understand what staging area is, go back to the first episode. I've already explained that this concept there well. So, git commit, added a new file. Okay, so now if we go here, run the same command, we see on top of the first commit I already, on the commit here I already created another commit, right? So let's explore what the second commit is. Git cat file 4241. Okay, that's good enough. 4241. You see, still it points to a tree, but on addition to, so it's a commit. It's a commit, points to a tree, but in addition to the tree, it also points to a parent. What the parent is, as you can see, it's F145. It's exactly the first commit. So we can guess that the second commit points back to the first commit. It has the kind of like a pointer to the preceding commit, which is a new information for us here. So okay, let's check what the tree is. Git cat file -p. We now check in the tree. The tree contains, okay, it's a readme file, which is the same old stuff from the first commit. Actually, the hash key hasn't changed because the content of this readme file is the same, so Git does not update this blob. However, there's a cd folder. As you can see, if it's a folder, then it's a tree. So a tree points to another tree, which is the cd, and then we're gonna git cat file -p points to blob. Blob is the cd, and we assume that if we git cat file this blob, then 1889, you see that's the content of the cd.md file. So that's what actually happens under the Git. So 10 days of Linus work is making this tree. Of course, there's something else. I'm just kidding here, but at least it's easier. It's really easy concept, okay? There's always a commit, and then commits always point to a tree. So these two things are always there. And then according to your folder structure, if it's a folder, and then it's a tree. If it's a file, then it's a blob. And then the blob contains the file content, right? And then, of course, the following commit always has the tracing back parent information, tells what is the preceding commit, so that the following commit always knows what is the preceding commit. As simple as that. Okay, actually this is the commit. So if we make more commits, of course it's like add additional commits behind this 4241. And then what is the branch? In Git we do a lot of branching stuff, and by default we have the master branch. Actually my shell here already tells me I'm under the master branch. So if I run git branch, yeah, it tells me I'm under the master branch, the star, and then that's the only branch I have. So what does it really mean? Let's run the tree again. As you can see, we have a ref folder, there's heads, and there's a master. Let's cat ref heads master. You see, the master file contains just a plain text. It's a hash ID again, 4241. 4241. This is the second commit we just made, okay? Which means your master branch points to this specific commit, and that commit, of course, then points back to its preceding commit. And then if there are more commits in the history, then obviously it's a chain, right? If you grab this mast file, and then that mast file tells you what's the latest commit in your master branch, and then succeedingly or subsequently, you go back to the previous or the commits. So that's exactly how a branch is. So a branch actually is a pointer that contains a hash ID of a commit, as simple as that. So that's why in Git, when we create a new branch, we'll branch off from existing master branch. For example, if I git branch -b dev, I think it's -b dev. I know, git branch. How do I create a new branch? Was it checkout? I remember checkout dev. So here, oh yeah, as you can see, I switched to the dev branch, and now if I do the tree, as you can see, in addition to the master, we have the dev branch. Okay, so guess out. If I now cat this dev branch, what would it say? It should point to the exactly same commit as the master branch, right? Because they are pointing to the same place. It's the 4241. If I go back to log file, you can see not only the dev branch is here, we have a master branch here as well. So both the two branches pointing to the same commit. So now in the dev branch, let's try to update the README. Dev branch. Let me commit. Now I add the file and add the text message. That's it. I combine the two commits into one, so I can make commit faster. And now if I come back here again, you see the master branch still points to the 4241 because it doesn't change. And now in the dev branch, what I made a new commit is under the dev branch, and of course the dev branch has advanced one more commit. It's 5.3, and on the screen you can see that the hash code is 5.3 something, and the dev actually points to the 5.3. Okay, there's another one, head. let's use the tree again. There must be a head information here. You can see this head. There's another like logs something. It contains the history of the head, dev and master branch where they were pointing to, but it's not relevant here. So we pay more attention to this .git/head. Let's see what it is. Head. Oh, you see, this is also one-line content. It tells us head points to the dev branch. That's what it means. I'm currently under the dev branch. So if now I git checkout master, right? I switch back to the master. If I now cat the head points to the mast. You see, it changes to the master. So the head actually means what is the active or activated branch. Of course, how would I explain that? Head can point to a branch, either it's the dev or master, whatever, or head can also point to a commit. You see, I now go back to the commit, and then if I run this, you see the head is here, and it points back to the first commit, while the dev and the master, they are on the second and the third. So the head can point to whatever, either commit or branch name. Okay, so I'm currently under this first commit, and of course the file content is from the first commit. As you can see, the CD folder is gone because it wasn't there when I make the first commit, and if I cat the README file, it doesn't contain the changes I introduced in the second commit. Okay, so this basically is about Git. You move the head, and then the Git repository restores the contents from certain commits. If you point the head to the master or the dev or other branches, then it will point to that branch, and of course it will only how to say retrieve the snapshot of content from that specific commit the branch points to. It's kind of a little bit hard to explain in words, but hopefully you get my point, and then do spend more time to play around with this. This is the fundamental part of how Git works, and as you can see, it's not rocket science. So once you understand these, and then create more repository, then try play around with different commands, and then I think you will slowly grab the Git knowledge. Okay. So this is about this episode. If you have any questions or you have comments, please leave comments below. I'll try my best to answer. And in the following episode, what we're gonna talk about is like a remote repository, GitHub or Bitbucket. I think I will use the GitHub as the demonstration place. It's more popular in the open source area, and also it has a lot of more fancy tool for us to check the difference and to resolve the conflicts in GitHub. Okay, that's the end of the session. Hope you guys liked it, and then let's win Git together. See you guys later.